Welcome to implement ISO 14067 carbon accounting step by step. In the next 15 minutes, we'll walk through the complete process of quantifying product carbon footprints, from defining the goal and scope of your study through life cycle inventory analysis, impact assessment, and reporting. With ESG reporting requirements tightening globally and supply chains demanding carbon transparency, ISO 14067 gives you the internationally recognized methodology to measure, report, and ultimately reduce your product carbon footprints. Let's get started. Let's start with the foundations. Understanding what a product carbon footprint is, how ISO 14067 defines it, and what makes this standard essential for modern business. Before diving into the methodology, let's define the key concepts that ISO 14067 is built on. A product carbon footprint, or PCF, is the sum of all greenhouse gas emissions and removals associated with a product throughout its entire life cycle. This includes raw material extraction, manufacturing, distribution, use, and end-of-life disposal. It is expressed in kilograms of CO2 equivalent. Life cycle assessment is the systematic methodology that underpins ISO 14067. It evaluates environmental impacts from cradle to grave, covering raw material acquisition, production, use, and disposal. ISO 14067 applies the LCA methodology specifically to greenhouse gas emissions, following the framework established by ISO 14040 and ISO 14044. The functional unit defines what you are measuring the carbon footprint of. It quantifies the performance of the product system. For example, 1 liter of packaged milk delivered to a retail store, or 1 kilowatt-hour of electricity generated. The functional unit ensures that carbon footprints are comparable across different products that serve the same function. The system boundary defines which processes and life cycle stages are included in your carbon footprint calculation. ISO 14067 supports cradle-to-gate boundaries covering raw materials through manufacturing and cradle-to-grave boundaries covering the entire life cycle. The boundary choice directly affects the completeness and comparability of results. ISO 14067 requires you to consider greenhouse gas emissions across the full product life cycle. Here are the key stages. The first stage covers raw material acquisition. This includes extraction of natural resources, initial processing of raw materials, and transportation to the manufacturing site. For many products, raw material extraction accounts for the largest share of the carbon footprint, particularly for materials like metals, cement, and agricultural commodities. Manufacturing covers all production processes, including energy consumption for heating, cooling, and machinery operation, process emissions from chemical reactions, waste generation and treatment, and internal transport within the facility. This stage is where your direct operational control is greatest. Distribution covers transport from factory to customer, including warehousing and retail. The use phase covers energy and material consumption during the product's operational life, maintenance, and repair. For energy-using products like vehicles and appliances, the use phase often dominates the total carbon footprint. End of life covers what happens when the product is discarded. This includes collection and transport to waste facilities, recycling and material recovery, energy recovery through incineration, and landfill disposal. Recycling can generate credits that reduce the overall footprint, while landfill of organic materials generates methane emissions. Organizations often wonder how ISO 14067 life cycle stages relate to the Scope 1, 2, and 3 framework used in corporate carbon reporting. The GHG Protocol Scope framework is organization-focused. Scope 1 covers direct emissions from sources you own or control. Scope 2 covers indirect emissions from purchased energy. Scope 3 covers all other value chain emissions. This framework is used for corporate-level ESG disclosure and carbon reporting. ISO 14067 is product-focused, following the physical flow of a specific product through its life cycle. Cradle-to-gate covers everything up to the factory gate. Cradle-to-grave extends through use and disposal. This product-level analysis enables carbon labels, product comparisons, and specific reduction strategies that complement organization-level scope reporting. Now let's walk through the 4 phases of conducting an ISO 14067 carbon footprint study, from goal definition through reporting. ISO 14067 follows the 4-phase life cycle assessment framework from ISO 14044, applied specifically to greenhouse gas emissions. Phase 1 defines the goal and scope of your study. You specify the functional unit, set the system boundary, identify cutoff criteria for excluding minor processes, define data quality requirements, and document allocation procedures for multi-product processes. This framework document guides all subsequent work. Phase 2 builds the life cycle inventory. You collect data on all material and energy inputs, product and co-product outputs, emissions to air, water, and soil, and waste generated for every process within the system boundary. Data sources include direct measurement, supplier data, industry databases, and emission factors. Phase 3 converts inventory data into the carbon footprint result. Each greenhouse gas emission is multiplied by its global warming potential factor to convert it to CO2 equivalents. For example, 1 kilogram of methane equals approximately 28 kilograms of CO2 equivalent. The sum gives you the total product carbon footprint. Phase 4 interprets the results. You identify emissions hotspots showing which life cycle stages and processes contribute most, conduct sensitivity analysis to understand how data uncertainty affects results, draw conclusions about where reduction efforts will have the greatest impact, and develop actionable recommendations. Data quality is critical to a credible carbon footprint. ISO 14067 establishes a clear hierarchy for data sources. Primary data from your own operations is the gold standard. This includes direct measurement of energy consumption and emissions, metered utility data, production records, and waste manifests. Primary data should be used wherever possible, especially for processes under your direct control and for significant contributors to the footprint. Supplier-specific data is the next best source for upstream processes. This includes supplier environmental declarations, product-specific emission factors from your actual suppliers, and independently verified supplier carbon data. Engaging suppliers for specific data significantly improves the accuracy of your footprint. Secondary data from recognized databases fills gaps where primary and supplier data are unavailable. Industry-standard databases like EcoInvent and Gabi provide average emission factors for thousands of materials and processes. Government-published emission factors cover energy grids, transport modes, and waste treatment methods. Proxy and estimated data is used only as a last resort for minor processes. This includes data from similar products or processes, engineering calculations and estimates, and published literature values. Any use of proxy data must be documented and justified, and its impact on the overall result assessed through sensitivity analysis. The business case for carbon accounting has never been stronger. Here is why organizations are adopting ISO 14067 now. The EU Carbon Border Adjustment Mechanism requires importers to report embedded carbon in products like steel, cement, and aluminum. The Corporate Sustainability Reporting Directive requires detailed ESG disclosure, including product carbon footprints. Without ISO 14067 compliant carbon data, companies risk losing access to European markets. Major corporations are cascading carbon requirements through their supply chains. Apple requires suppliers to report emissions and transition to renewable energy. Walmart's Project Gigaton tracks supplier emission reductions. Automotive OEMs demand life cycle carbon data for components. ISO 14067 provides the methodology these buyers recognize. Carbon labels on products are becoming a competitive differentiator. Consumers increasingly consider environmental impact in purchasing decisions. Environmental product declarations based on ISO 14067 data provide transparent, third-party verified carbon information that builds trust and brand value. Beyond compliance, carbon footprinting reveals operational improvement opportunities. The emission hotspot analysis often identifies energy waste, material inefficiency, and transport optimization opportunities that reduce both carbon emissions and costs simultaneously. Many organizations find that their carbon reduction strategy pays for itself. Let's close with the most important lessons from ISO 14067. First, the functional unit and system boundary are the most critical decisions in your carbon footprint study. They define exactly what you are measuring and what is included. Errors here propagate through the entire analysis and make results incomparable. Invest time to define these correctly before collecting any data. Second, data quality determines the credibility of your carbon footprint. Use primary measured data for the processes that contribute most to the footprint. Document all assumptions, data sources, and estimation methods. Transparent methodology builds stakeholder confidence in your results. Third, the real value of carbon footprinting is in the hotspot analysis. Identifying which life cycle stages and processes contribute the most emissions enables you to focus reduction efforts where they will have the greatest impact. This transforms carbon accounting from a reporting exercise into a strategic improvement tool. And fourth, ISO 14067 compliance is rapidly shifting from voluntary to mandatory. EU regulations, major buyer requirements, and investor expectations are making product carbon footprinting a market access requirement. Organizations that adopt the standard early gain competitive advantage and avoid scrambling to comply under pressure. That wraps up our overview of ISO 14067. In the full Udemy course, you'll get detailed lessons on each phase of the carbon footprint study, practical calculation templates and data collection tools, worked examples with real product carbon footprints, and guidance on reporting and third-party verification. Use the course to build carbon accounting capabilities that meet regulatory requirements and drive real emission reductions. Thank you for watching. If you found this overview helpful, subscribe to the channel for more content, and check the description for the link to the full course. See you in the next video.